Flight controllers in the White Flight Control Room at NASA's Johnson Space Center in Houston successfully performed a burn to insert Orion into a distant retrograde orbit by firing the Orbital Maneuvering System engine for 1 minute and 28 seconds at 4:52 p.m. Central Standard Time, propelling the spacecraft at 363 feet per second. Shortly before conducting the burn, Orion was traveling more than 5,700 miles above the lunar surface, marking the farthest distance it will reach from the Moon during the mission. While in lunar orbit, flight controllers will monitor key systems and perform checkouts while in the environment of deep space. The orbit is distant in that Orion will fly about 40,000 miles above the Moon. Due to the distance of the orbit, it will take Orion nearly a week to complete half an orbit around the Moon, where it will exit the orbit for the return journey home. About 4 days later, the spacecraft will harness the Moon's gravitational force once again, combined with a precisely timed lunar flyby burn to slingshot Orion onto its return course to Earth ahead of splashdown in the Pacific Ocean on Sunday, December 11th. On Saturday, November 26, Orion spacecraft will break the record for farthest distance traveled by a spacecraft designed to carry humans to space and safely return them to Earth. This distance is currently held by the Apollo 13 spacecraft at 248,655 miles from Earth. Orion was specifically designed for missions to carry humans farther into space than ever before. On Artemis 1, engineers are testing several aspects of the Orion spacecraft needed for deep space missions with crew, including its highly capable propulsion system to maintain its course with precision and ensure its crew can get home, communication and navigation systems to maintain contact with the ground and orient the spacecraft, systems and features to handle radiation events, as well as a heat shield that can handle a high-speed re-entry from the Moon. Both distance and duration demand that spacecraft must have systems that can reliably operate far from home, be capable of keeping astronauts alive in case of emergencies and still be light enough that a rocket can launch it. Artemis 2 will test the systems required for astronauts to live and breathe in deep space. Long-duration missions far from Earth drive engineers to design compact systems not only to maximize available space for crew comfort, but also to accommodate the volume needed to carry consumables like enough food and water for the entirety of a mission lasting days or weeks.